Hi, welcome to Unit 3 on our math and logic stuff. What I'd like to do here is show you how to complete the worksheet number 1. In this case it's called Simplifying Equations. It's the first worksheet that you'll find in Unit 3. What I'd like to do is just show you and talk through how we are going to do these problems. First of all, if you look at the first problem, it is AB plus BC plus AC. Simplifying Boolean expressions has a handful of techniques. One of those techniques is to always take out what's in common first. Now in Boolean math, we would want to look at two terms at a time. In this case we have three terms, 1, 2, 3. I'm going to look at the first two terms and ask myself what's in common. As I look to see what is in common, I see that there's a B in both terms, so I'm going to take the B out and replace it with A plus B. A plus C, my bad. And I still have plus AC out here. As I look now, there is no other items I can take out that are in common. In fact, problem 1 is now complete. Problem 2, though, however, will have quite a bit more math involved. As I look at problem 2, I see two terms, AB, ABC. I notice that AB are in both terms, so I will take out AB, write down 1 plus C, which is left over. Now Boolean math, Boolean algebra, has a rule that says any letter plus 1 is always 1. So I can continue to correct and simplify AB times 1. My final answer is AB. As I move to problem number 3, you might notice it is the exact same problem, just written different. AB is in common, so I'll take out A and B. I'm left with C plus 1. C plus 1, though, is 1. A times B times 1 is AB again. The next problem, I have three terms, ABC, A not B, C plus AB. As I look ahead here, I will want to try to pair up two terms that have some things in common. Yeah, you're going to have choices. What I mean by that is I have AB in common with this term and this term. I have AC in common with these two terms. And really, it doesn't matter which you take, just move forward with your math. In this case, I'm going to take out AC. When I take out AC, I'm going to be left with B plus not B. And of course, the AB is still attached. Now in Boolean, B plus not B is always 1. So I have AC times 1 or AC. And I still have plus AB here. To finish off the math, there's an A in common. I'll take that out, and I'm left with C plus B. The next problem. Again, as I look ahead, I see that these two have AC in common, so I will take AC out, and I'm left with B plus not B, and not AC. As I continue to look, I see that this simplifies down to 1. And then I notice I have C in common with both of these, with A plus not A, which in the end simplifies down to simply C. And then the final problem. I am going to take a b and a c out of the first two terms. I'm left with a plus 1. And of course I still have ac plus ab not c. And if I notice here, that will go down to bc plus ac plus ab not c. The next step I do will definitely maybe boggle some minds simply because it's a new rule. I'm going to look at the second two terms, and I'm going to notice that a is in common, and I am left with c plus b not c. Over here I still have bc plus all that. And the strangest rule, I think, personally, in Boolean algebra is when you have one letter plus two letters. When you have one letter plus two letters, you can split it into two parenthesis sets. C going in the front of both, followed by B in the first one, and not C in the second. One big question is, why would I want to do that? Well, if I notice C plus not C, that is 1. And so my answer will reduce to BC plus A times C plus B. Hope it helps. If it does, let me know. I'll put it together more if we need to. And of course, always ask questions. All right, appreciate it. Thanks. Good luck.